In this video, we will learn measurements of position. The first one we are going to learn is percentiles. The P's percentiles is a value such that P% of the observations fall below or at that value. In other words, 1 minus P% of the observations fall above that value. You may have received your score report from SAT that it says your SAT score of 1200 was the 90th percentile. This sentence actually means 90% of those who took the exam scored between the minimum score and 1200. Only 10% of the scores were higher than yours. The next measurement is quantiles. Quantiles split the data into 4 parts, each containing 1/4, in other words 25% of the observations. First quantile is denoted by Q1, or 25th percentile. It means 25% of the data falls below Q1, or first quantile, and 75% of the data falls above Q1. Q2 is actually something we have already known. It is just the median, the 5th percentile. 50% of the data falls below Q2 and 50% of data falls above Q2. Q3 is a third quantile. It is also the 75th percentile. It means 75% of the data falls below Q3 and 25% of the data falls above Q3. Here are steps to find the quantiles. The first step is arrange the data in order. The second step is find Q2, the median, which is the middle of the entire data set. Then you split the data at Q2. If n is odd, then we do not include Q2. At this point, you should have 2 equally split halves to the data set. Make sure both halves have the same number of observations. Then you want to find Q1. It is the middle of the first half of the data. Then you want to find Q3. It is the middle of the second half of the data. This animation shows us how to find quantiles. Interquantile range is the next concept we need to understand. Interquantile range is the middle 50% of the data. It is also the difference between the third and the first quantiles. So the formula of interquantile range, it is the difference between third quantile and first quantiles. Is the interquantile range affected by the outliers? By the formula, we can say the answer is no. Because we only look at the middle of the data set, not the extreme values. Fine number summary is made up of the following: the minimum, first quantile, second quantile, third quantile, and the maximum. Generally, on exam, you are asked to find the fine number summary. Make sure you know which 5 values make up the fine number summary. Box plot is a visual representation of the fine number summary. To create the box part, we draw 3 equally height vertical lines at the quantiles. Add 2 horizontal lines to connect the 3 vertical lines to form a box. To create the whisker part, from the middle of the vertical line, starting the box, draw a horizontal line out to the minimum value. From the middle of the vertical line ending the box, draw a horizontal line out to the maximum value. In this example, I will show you how to calculate fine number summary, interquantile range, and create the box plot for the following values. The first step is arrange the data in order. Then we want to find the median, or the second quantile. Note that the sample size is 12. And 12 is an even number. So the Q2 should fall between n divided by 2, which is 12 divided by 2, 6, and n divided by 2 plus 1 equals 12 divided by 2 plus 1 equals the 7th number. So the median should be the average of this number and this number. So that's why we use 6 plus 7 and divide by 2, which equals 6.5. Then we split the data at Q2. Since sample size is 12, which is even, then the median falls between two values. Split the data set into two equal halves at the median. We know that both halves have 6 observations. So we want to find Q1, which is the first quantile. We can do so by find the middle of the first half only. Since the first half only have 6 data, which is even, the middle falls between two numbers at the n divided by 2 and n divided by 2 plus 1 positions, which is the third and the fourth positions. We arrange this number to get Q1, which is 5 plus 5 divided by 2, which equals 2. So the first quantile is 5. Then we want to find the third quantile. We find the middle of the second half only. The middle falls between two numbers at n divided by 2 and n divided by 2 plus 1 position, the third and fourth positions. The average of those numbers to get the third quantile, which is 7 plus 7 divided by 2, which equals 7. Next, we want to find the 5-number summary. The minimum is obvious, and the maximum value is also easy to find. In the last slide, we have shown how to find the first quantile, second quantile, and third quantile. By definition, the interquartile range is calculated by the difference between Q3 and Q1. And Q3 is 7, Q1 is 5. So that's why the interquartile range is 2. This animation will show you how you can draw box plot. So this pink line is drawn based on the first quantile. The second line is drawn by the second quantile, or the median. The next line is drawn by using the third quantile. Then we make it as a box. Then we locate the minimum value at 1. Then we locate the maximum value at 9. Here we complete our box plot. We can also indicate the mean by using a triangle here. This is another example about how to find 5-number summaries. We arrange the data in order first. Then we need to find the second quantile. Note that the sample size is 11, and 11 is odd. So the Q2 should fall at the 6th position. Then we split the data at Q2. Since sample size is 11, we do not include the median in either half. We split the data set into two equal halves at the median. Next step is find the first quantile. We find the middle of the first half only. The first half only have 5 numbers, which is odd, so the middle falls at the third position. Hence, the first quantile is 13. Next, we want to find the third quantile. We find the middle of the second half only. The second half has 5 numbers, and 5 is also odd. So middle falls at the third position, which is 30. Next, we can find the interquantile range. By its definition, we use Q3 and subtract Q1. We have 17 for the interquantile range. Then I will show you how to draw box plot based on 5 number summary. Again, this line is drawn by Q1. The second line is drawn by Q2. Third line is drawn by Q3. Then we make it as a box. Then we find the minimum value and draw a horizontal line. Then we find the maximum value and draw a horizontal line. We use a triangular to represent mean.